welcome to section 15.7, triple integral in cylindrical coordinate. Cylindrical coordinate. Okay. What is a cylindrical coordinate? For some point x right here, here come y. Yeah. Now we can get the point right here to be instead of x, y, right? We can use the radius r and the angle theta. So this point right here is the same as r theta, theta r. Next, to get the z, right, you just got to go up here. It's going to be this point is theta r z. That is what a cylindrical coordinate look like. Convert three minus 7 to cylindrical coordinate. Okay, so the point is in rectangular coordinate. We just want to do the conversion. So that means we have to figure out the angle theta, the radius r and z. The angle theta is the, hopefully you guys know from polar coordinate. The angle theta is the arctangent of y over x. Work it out. So it's going to be a arctangent of -3 over 3, which is the, no, this is the arctangent of -1 and arctangent of -1. Well, make sure you use the correct quadrant. Is that this is very important though, because we're gonna have to sketch up the point here later. X is 3, y is -3. So the angle is right here. See, this is the angle theta. In the fourth quadrant, so just be careful, right? Well, in the fourth quadrant, and this -1, it's going to be a 7 pi over 4. Okay, so that is how we get the angle theta. And then next is the radius r. Well, we all know, right? Radius is the root of x squared plus y squared. Root of 3 square plus minus 3 square, and so this would be 3 root 2. Okay. Well, what about z? Z is the same, right? Z is just z, x, y, z. So z here is the same as the z in the rectangular coordinate. So that would just be -7. Okay, so x equal 3, y equal -3. So I mean I have to go. There's 3, -3 somewhere right here. Oh, and then z is negative, so it could go down here. Okay. So let's say -3 is right here. -3. Well, we got to get the coordinate here correctly here. Okay. Oh, that look good. Right here, and then you go down until you get to somewhere is -7. Yeah, so that look good. Just it is parallel, so it look good. Okay, so 3 minus 3 minus 7. That is that point right there. Huh? Now let's take a look at the angle. Huh? Is the angle correct? Radius, everybody know. Huh? This the so here come the radius right here. Huh? Huh? That does look like 3√2, right? And then the angle go from here to here. Right? This is the angle theta. It does look like 7.4 because it is in the fourth quadrant. Yeah. Well, here's the cylindrical coordinate. Two pi of 3. Two and 1. 2 rectangular. Coordinate. X or cosine theta, which is the, well, radius is 2 cosine 2 pi over 3. And this would be 2 cosine of 2 pi over 3 is negative 2. So it's -1. Y is all sine theta. 2 sine 2 pi over 3. So that would be 2 and √3 of 2 √3. And then the last one is z. Well, z is z. So that is 1. So 2 pi over 3 is in the second quadrant. Somewhere right here is 2 pi over 3. And then the radius is 2. That's the radius. That z go up by 1. It is my point. 2 pi over 3, 2, 1. Okay, let's check with the rectangular coordinate. It does match up. Before we can do some triple integration, it's just a few more things that you need to know. You got to be able to describe surface using cylindrical coordinate. So surface description using cylindrical coordinate. Example, describe them without sketching. So here come z equal r √x square plus y square. Look at this. It's a cone. Okay, so here come b. Okay, so if we have R is equal to, now what exactly is this thing here? Yeah, right, I convert to rectangular coordinate. And we are root of x squared plus y squared equal to. So x squared plus y squared equal 4. X squared plus y squared equal 4. This surface is a yeah, maybe it's a good idea to sketch out these things so that you get an idea of what is going on here. Even though say don't sketch them. So the cone okay, and then the other one is the a cylinder. Yeah. Become C. The angle theta is the opposite. Convert. So it can be a arctan y of x is opposite. So that means y over x is the arctangent of opposite. And then from there you should be able to know. What do we have? We have a y over x gonna be a arctan of opposite is the root 3 over 3. So that means y is the root 3 over 3 x. Well, if you see something like this, it has to be a plane. Yeah. Yeah, it's this plane right here. Huh? So 3 triple integral in cylindrical coordinate. Look at this. Yay. Hey, awesome. Learn a new trick. There is the block right here, right? It's another way to see the block. But then the best way to see the block is gonna be this one. The best view. Block. Okay, so if you look at the sample block, then you will see that, oh yeah, we have a change in the radius, right? And then we have a change in the arc length, and then we have a change in Z. So this block is just change in radius. Change in arc length. And change in height. Yeah. Radius and arc length, that gives you the base area times height, that gives you the volume. So as you can see, that is why The dv here is the base area time height. See, dv is base area time height. Base area is RD theta. Height is just dz. So you see this as, well, because z vary, right? We want to put z on the inside and then the angle theta is all the way outside. Or dz drd theta. 9 minus x square minus y square root of x square plus y square dz dx dy. Yeah, that's a very nice integral here, huh? As you can see, if you guys do this one directly, it can be pretty tedious work because of the square root right here. So what we can do here is that we can convert it to cylindrical coordinate. It's between 0 and 9 minus x square minus y square. 9 minus x square minus y square equals z. That is a paraboloid. And then we say that x is between 0 and root of 9 minus y square. And here come y. If 3 and 3. Okay. This is not a full paraboloid because the value of y can only go from -3 to 3, and then x can only go up to the upper half of the circle, because it looked like if 3, and then this the upper half circle right here. The paraboloid can only go here, so here come the paraboloid. Here come number 9 somewhere right here. Project the solid onto the XY plane. You can get to see the region D very clear. It's region D right here. dA is R, drd theta. We need to know where does the angle and where does the radius go from. Radius, that is just part of a circle, so the radius have to go from 0 to 3. Anybody can tell me where the angle go from? The angle theta. Q4 and Q1. So come here. Yeah. Need pi 2 to pi 2. Yeah. dz dx dy is the dz or d theta, so it's going to be r dz d theta. So we know that the radius r go from 0 to 3. The angle theta minus pi over 2 to pi over 2. X squared plus y squared is r squared. Right? And so this is 9 minus r squared. Right? Let's evaluate this thing here. So, no. Well, needed pi over 2, 0 to 3. And then as you can see, this is just the r square, right? In here is going to be a integral of z is, dz, just z. Right? Then z go from 0 to 9 minus r square. Right? D or d theta. Yeah, how nice. It's just this. Well, it's the r square and then times 9 minus r square. Well, there's no theta in here, so you can just do negative pi over 2 to pi over 2 d theta 0 3. It's the 9r square minus r to the 4th dr. Well, and what do we have here? We have this to be a pi over 2 minus pi over 2, so that is just pi. For this one, it's going to be a 9 r3 over 3 minus r5 over 5. And 0 to 3. Okay, I'm going to work it out here. So pi and then 3 times 3 square is going to be 3 times 3 to the 3, so it's going to be 3 times 3 cubed minus, oh my god, 3 to the 5 over 5. So that's it. The answer is 162 pi over 5.